All right, welcome to the basics of residential green remodeling and new construction. This is our continuing series. Within this series, we are covering the 5 pillars of green building: materials, energy, health, water, and place, one within each module. Our last module, we covered health in module 3, looking at indoor environmental quality, indoor air quality, physical health, mental well-being, as well as some of the things that can impact more sensitive people and clients of yours within the construction and remodeling process. In this session, we're going to be covering materials in Module 4. Sometimes these are broken up in other programs and referenced as materials and resources, material conservation, durability, recyclability, as well as sometimes these get mixed into certain health impacts of materials. But for our sake, we're just going to call it materials and then sort of drill down into what each of the aspects we look for when considering materials during the design, remodeling, and new construction process. So very important, number one, is keeping water out of a house, similar to having a thermal enclosure that is sealed, such as we covered in Module 2 under energy. So is it important to keep a water enclosure around the house and to keep water from the time it hits the house to where it is in the ground to where it goes away from the building material. Time and time again, we see focuses on those first 2 categories that we covered, energy and health. But if you don't if you focus on those and don't keep water out of the home, the house can lead to mold, rot, which has huge health impacts, but then also material waste and otherwise older materials that could have been preserved for quite a long time, now have to be replaced with something new. So it's very important to keep water out, and this is one of the things that we look at with durability and longevity. We know of buildings that have lasted, over 1,000 years in other countries, and so we see homes being built, that are only going to last maybe 30 years in this country, simply because there's failures where water gets in. And it seems very simple. A lot of it is sometimes built into code, but other times it's some stuff that can get missed. So looking at site and foundation, so keeping water away from the foundation through slopes, through downspouts, through well-draining soils, sandy soils, depending on that. Again, keeping that water away from there. And also, this plays into basements. If you're finishing an existing basement, you do want to do something like a bulk moisture water test to, number one, determine if there's moisture present in the basement, and then seal it and get it out of there in existing homes. It's very important. Most building scientists recommend just leaving basements alone entirely, not finishing them, because they're usually doomed to fail regardless. There's a lot of technology out there that can be used to avoid that. That's just sort of the first thing. And then if you're building a new home, recommending to not build a basement at all, because again, it can lead to a lot of issues. And just doing a slab on grade, if there's flooding or what have you, basement's the first place that's you go down in the basement, it's moldy, it's mildewy. Up here in Michigan, we've just got some nasty basements. So that's one thing to consider when you're looking at this, is doing that concrete moisture slab test, water testing. Wall assembly is usually a little more straightforward, but again, depending on what climate you're in, if you've got more driving rains, certainly you want to use aspects to keep water out of the wall assembly and make sure water dries out of the wall assembly as well. Roof assembly, roof leaks occur all the time, sometimes just because of things out of our control, but other times because of failures in the roof and failures in the design, failure in the builder to put the shingles on correctly and not having anyone check that, all the way to using sealants, proper sealants and flashing around the roof and where the edges and pitches come together. All of those to help keep water out, to flat roofs that have failing membranes. Again, if your roof, you drive around and you see those old barns, really old barns, but they've got brand new nice metal roofs on them. That's because, that's the #1 place where water is going to be coming in. And so this is a great way to direct water away from the house, away from the site, and keep it dry. And then, of course, also the types of materials being put into the house and whether they're adding moisture or potential water issues within the home. Very important during the materials and durability selection process. So this is a really great resource, and the link is in the handout, and you can check the link out. Basically, this is looking at the Energy Star version 3 certification. But what I wanted, the first 2 parts are more focused on energy and health to some degree. Very great resources there as well for building a home. We'll get into that in a later section, but what it does is it has a really great, well thought out water management system checklist that's built for you to use with your clients to incorporate into your own design plans, incorporate into your own construction process, and utilize. And so if you drill down into the water management system, it has those 4 categories that we have: site, wall, roof, and materials. And then each one of them has very specific links to each of those strategies. And so if you drill down into each of those links, what you get is something really neat. You kind of get the basics, the scope of work that you might want to put into a contract, descriptions, success stories, variations by climate, some different training resources, CAD files, code compliance, and more. Some of these have videos. So these are really great. It says register or log in, so that's only to provide feedback. But this is a free resource on the pnnl.gov website, again. And so this is one I wanted to single out here. And this is something we see all the time when you're building a new home, or even when you're doing a renovation of the bathroom. This is a great time to get into the shower enclosure and put up a non-paper face drywall backer board. And so again, very important to keeping mold and moisture out of the bathroom, along with the proper bath ventilation that we covered in the last session. Mold and mildew can build up behind the tub and wall, and so having a, again, non-paper face backer, like a Den's Armor or fiber reinforced gypsum, or a very airtight, watertight, dry, tile sealed approach. Again, very important to help keep your clients' bathrooms not moldy. But anyway, check this resource out for everything to do with water, and then Energy Star also has some great resources online for water management throughout the entire house. Keeping on that concept are vapor barriers, and so here's some of the different ways vapor barriers are rated. And so a vapor retarder is something that has 0.1 perm or less. And so again, this concept of putting these in especially in the walls, and keeping moisture out of the house, keeping water out of the house can be very important. Again, making sure that the water dries out of the house as well when water does get in, or eventually does get in. And you can check out some more resources at buildingscience.com there. Lots of great resources there, and education and studies on wall assemblies that keep water out. Some other thoughts that are going out there is this concept of permeable versus vapor barriers, or versus impermeable barriers. And the argument from others, and we have a session that's coming up on this called Walls That Breathe, is the concept that walls that breathe. So not walls that breathe air. We don't want the walls to breathe air, remember, from the last session, the health session, but we potentially may want our walls to breathe moisture. Think of your skin on a hot summer day when you're sweating, that's moisture coming out of your skin. And so this idea that potentially maybe controlling water is sort of a fool's errand, and we never will be able to. So what we want to use are materials, different types of materials out there, and one of those in that foam-free design session that we talked about in the last module in health. Also, we have some items on that on the concept of why you're going foam-free is to have more permeable barriers that, again, allow water to move in and out of the house as opposed to getting trapped in the wall and causing rot. Following that concept and then taking a little bit further is the idea of natural building and natural construction. Typically, natural construction has more of this idea of being more permeable and, again, allowing water vapor to pass in and out of the house. But some of the concepts, like the top left there, are straw bale. On the right there is straw clay. So mixing straw with clay to make a more solid substance is also being used. On the bottom left there is natural clay plaster walls, which can serve many purposes. So it's taking place of the drywall. It can be made of, well, first of all, to back up, all of these can be made from locally, depending on where you're at, locally sourced materials, thus reducing the time and travel of materials, thus keeping money in the local economy, and also, you're reducing your impact by using more natural materials, less toxic materials. One of the neat things that I've learned about clay over here on the right is that actually clay is a waste byproduct of some sites when they're digging the foundation. And so imagine if instead of hauling that clay away to a landfill, we reused that clay, created a business model for it, and reused it in the construction of our buildings and our walls. And they even have, I've heard of buildings up to 2-3 stories tall using a straw clay approach. But on the left there, bottom is again with the natural clay plaster, so that allows the wall to breathe. It's a more natural material. There's even some studies to show that it perhaps could be could actually capture moisture in the wall and retain it and expel it instead of having it cause mold issues. And then another neat thing, if you look in the middle there, well, several more benefits of these types of design. If you look in the middle there, you've got a truth wall, so again you can kind of see behind the walls what's going on. And then you've got this natural heart shape, but that really speaks to what you can do with these natural clay walls. And there's a lot of designers out there that design, like we talked about in our last session, more biophilic walls, more natural shapes and patterns into walls, and so that can bring more biophilia and better mental health into the home. So there's a ton of benefits from utilizing these types of materials and resources, from being locally sourced, being local, creating or helping the local economy to more natural, non-toxic. But some of the things, obviously these types of materials are used quite a bit in the American Southwest and other parts of the world where it's a little bit drier. Part of the reason for that is, like in the cold weather climates, there's a lot of concern of moisture getting into these things and then causing a whole lot of rot. And so that is a huge concern. So where you've got massive temperature swings during the day, these types of systems are usually designed with what we talked about in our first session in energy module, the passive solar approach, to where the walls, in these types of systems, like when it's colder out or at nighttime, can let off heat that they've captured from the sun during the day. So they sort of have that passive heating and cooling built right into these natural materials as well. So if you want to learn more about that, on the top here, we did a really great session with Siggy Coco, who's just got a lot of great materials on her Facebook and online as far as inspiration on different types of homes and designs of how and why to do this in different climate zones. This one we sort of focused on cold and wet climates, which is where a real challenge of doing natural building is. And then you can check out strawclay.org, where there's a lot of resources throughout the country on how and why to utilize these more natural-based wall systems. And then also continuing with wall systems is the concept of prefabrication. And so some of the benefits of prefabrication are, weeding out, you have a manufacturing process So you're weeding out design flaws right there in the shop. You've got your specs. You can give it right to the shop, and they can design a really good well system. The other thing about prefabrication is usually shops tend to be a little more savvy on reduction of waste. So a ton of waste can be diverted from the landfill and usually can be reused right on site within the manufacturing process. On the right there, we've got SIPs, structurally insulated panels, which is a prefabricated panel, which has OSB and then foam in the middle, and then can have a chase in it for electrical panels. And again, those get designed in a shop, and then they get assembled on site by a builder. So again, reducing waste, having completely air sealed from an energy standpoint, reducing all thermal bridging that we talked about in the energy category. So lots of benefits for using SIPs. And then if you're concerned about the foam in the SIPs, they actually have structurally or prefabricated cellulose SIPs now. So they have a cellulose sandwich inside of them instead of foam. So you can check those out. They're being made, I believe they're being made in several places. One is near Detroit, Michigan. And then on the bottom there is insulated concrete form. So again, not necessarily prefabricated. Well, they are because the foam is made in a manufacturing process. So again, just like the SIPs, all waste with the foam gets usually recycled right back into the process. And then these structurally insulated panels get set right out on site, and then concrete gets poured right in between them, as way. And a lot of these are used for resiliency. So people use ICS for their bathrooms or for their entire house to guard against tornadoes or hurricanes, which gives the house a little bit more strength. They even make structurally insulated panels with concrete instead of the OSB to make a stronger home. So again, a lot of this reduced waste. Obviously, some of the drawbacks to concrete is it's a highly embodied energy, uses lots of energy, isn't always locally made. And so there are some concerns from a material standpoint about concrete. But overall, these systems are typically very energy efficient, and they're air sealed, and again, reduce a lot of waste during the process. So let's get into green products. And products have green attributes. So typically some of the questions that you would ask is the product made up of recycled content? And every different type of product is going to have a different level of recycled content that has been able to be innovated into it. And then there is post-industrial content, pre-consumer content. So post-industrial is sort of after the industrial process, how much of that gets recycled back into the material. And then there's consumer-based recycled content, so how much of the materials are made out of what consumers are recycling. And so those are all great questions to ask when your clients are looking to be greener. They want to probably have more recycled content. But sometimes recycled content isn't always the best. It doesn't make the best product all the time. It can lead to failures in the product. And so recycled content isn't the only thing to look at, but it is important to, as more products are being made, to start speccing ones that actually work, that are durable, and have higher levels of recycled content. Doing life cycle analysis or assessments on products is very important when you're working with your clients to speccing them. There are very formal life cycle assessment tools out there that you can utilize, but some very basic things is, to ask, where did the product come from? How local is it to the site? Is it, a lot of people ask, where is it mined? Where is it manufactured? Where is it extracted? Where is it distributed to? It's really important questions. Other programs look at, sourcing all materials within 500 miles, sourcing all within 100. Again, the benefits of this is reducing travel, reducing carbon emissions, and then, of course, trying to keep sourcing within the local economy, which can increase the local economy. Another question to ask of products is, where is it going at the end of its life? Is it destined? Is it designed really for the landfill, designed for the dump? And so, again, working with your clients to spec products that at the end of their life can be reused, renewed, recycled. Down at the bottom there, can be refinished, that can be composted or have biodegradable features are all very important. And then at that other bullet point, reusable, finishable, surfable, resurfaceable. Again, if you're doing an existing home project, starting to consider how much of the materials in the existing home can you keep in that home and refinish it or resurface it, doing hardwood floors, bringing it back to life rather than taking it out and throwing it away. And the bottom is sustainable manufacturing process. So there are different programs out there. Cradle to Cradle is one that looks at how much, it looks at the site manufacturing. It looks at the water efficiency, how much water is being wasted during the manufacturing. It looks at how much renewable energy is being used during manufacturing. It looks at what kind of toxins are being produced. So that's one really known example of Cradle to Cradle certification. But there are many other programs out there that look at sustainability and rate the manufacturing process of products. So again, that's another thing to work with your clients who are interested in this to to consider to help have better products that have a reduced impact on the back end. So some real specific things, the whole idea of avoiding illegal wood. So if if you can work with your client to spec wood that's local to your region, ideally, if not local to the country or at least within Canada. If not, then many programs require at the bare minimum you utilize the Forest Stewardship Council certification, which is a third-party certification chain of custody that ensures wood wasn't harvested illegally. And then SFI, or Sustainability Forest Initiative, is another growing one that, again, helps certify large swaths of forests. And even forests within the U.S. and Canada can be certified under these, and that also helps ensure that even though the wood's not illegal, that it has best practices, sustainability practices to not do overlogging. Overlogging can contribute to more greenhouse gases in the atmosphere, as well as destroy local climate zones and killing off species. So it's important to work with the client to spec, at the very least, legal wood, especially if it's going to be tropical wood. Another unique emerging idea is the idea of red list materials. So this idea that there's 12 particular chemical compounds made up of 52 individual ones that should be on the no list for specifying in any product, and should be avoided if possible. Polyvinyl chloride is one of them, and you may ask, why is that? PVC doesn't impact anybody, but PVC actually has a lot of impacts on the front end during the manufacturing process, exposure to chemicals of the people manufacturing it, and then on the back end, it's something that has to be landfilled or burned because it cannot be recycled. Avoiding flame retardants in products, again, which can cause cancer and other issues, especially to the younger population. Avoiding heavy metals like mercury in fluorescent lighting, very concerning. And so there's, you can check out at the International Living Future Institute a whole list of red list materials, and they have a whole program called the Declare that can help you find manufacturers that are declaring the fact that they're doing their best to avoid these materials in the product. And then have a plan right before you start your new construction or remodeling process. Have a plan, get an idea of how much waste is going to be generated. Do some research locally on where that waste can go when it's done, and how to keep it out of the landfill. You can work with local waste management organizations that will get you weight slips, which can be beneficial in many ways, for either for green building certification or just for something that you can tout, where you can say, hey, projects that we do have a 90% landfill diversion rate. And so having that plan is very important, making sure everybody on the job site, having it posted, understands where each item needs to go so that it can be basically diverted from the landfill. So whether that's recycled, composted, whether the asphalt shingles on the existing home are going to be created roadbed, you name it. Obviously, every local area has its own different challenges and opportunities, and so making sure to investigate those and then put a plan together. And then again, if you can do single source landfill where the waste hauler recycles it for you, that might make life a lot easier. And on that note, highly encouraging deconstruction. If there's an existing site where stuff needs to come down, to sort of scrub the idea of demolition from your language, from your dictionary, and replace it with deconstruction. So this whole idea that materials can be donated to local habitat restores or other organizations and be reused. Materials can be diverted from the landfill. And so there's a lot of extra benefits to this. There can even be tax credits to doing deconstruction or other incentives. But overall, it just takes a little bit of a change of thinking, again, rather than demoing a site, to doing a deconstruction process and reusing those materials. So that covers some of the real core basics of the materials section. Hope you'll be joining us next, where we'll be covering water efficiency, water conservation, and all things to do with water. Thank you.